Good morning, everybody. ನಾನು ಡಾಕ್ಟರ್ ಶರಣಮ್ಮ ಉಂಟಿ, ಅಸಿಸ್ಟೆಂಟ್ ಪ್ರೊಫೆಸರ್ ಇನ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್, ಗೌರ್ಮೆಂಟ್ ಫಸ್ಟ್ ಗ್ರೇಡ್ ಕಾಲೇಜು ಜೇವರ್ಗಿ, ಕಲಬುರಗಿ division. In the Fourier series, we have well known about the odd and even functions, that is f of x is equal to f of minus x is equal to f of x, and f of minus x is equal to minus x. That is the one kind of it is a even function, and one kind of it is a odd function, that is a f of minus x is equal to minus f of x. In this video, we have to go for the learning of the Fourier series of the odd and even function over the interval minus L to L. As we know about the single valued functions of the interval 0 to 2L, that is the even function is f of minus x is equal to f of x, and odd function is f of minus x is equal to minus f of. In the same way, for the single valued function of the interval minus L to L, the function even is f of minus x is equal to f of x, and the odd function is f of minus x is equal to minus f of x. Here the interval is going to be split. How means it is minus L to 0 and 0 to L. That is f of x is equal to phi of x for the interval minus L to 0, and the same in f of x is equal to psi of x for the interval 0 to L. f of x is even if phi of minus x is equal to psi of x, and f of x is odd if phi of minus x is equal to minus psi of x. For the example to the even and odd function, that is for the single valued function, let f of x is equal to minus x, and f of minus x is equal to minus x, that is equal to minus of f of x. Thus f of x is equal to x is an odd function. If we take the another example, that is f of x is equal to x to the power of 4, then if we put x is equal to minus x, then x to the power of 4 it becomes same. If we put x is equal to minus x, then minus of x is raised to 4 is equal to x to the power of 4, and that is equal to f of x. Thus f of x is equal to x to the power of 4 is an even function. In the same manner, we can say that if the trigonometric function sin of x, that is also a example for the odd function. For the splitting of the function in the interval minus L to L, that is f of x is equal to minus 6 in the interval minus pi less than x less than 0, and plus x in the interval 0 to pi. So that is psi of x is equal to minus 6, and phi of x is equal to x. Now phi of minus x is equal to minus of minus x, that is equal to x, and we know that it is equal to psi of x. So that means f of x is an even function. In the another case, for the example related to the minus pi to pi, or in case we can say that it is an example for minus L to L. L may be we know that L may be we can define in the terms of the radian or in terms of the real number. So that means f of x is equal to minus cos x in the interval minus pi comma 0, and plus x plus cos x in the interval 0 to pi. Here phi of x is equal to minus cos x, and psi of x is equal to cos x. Now phi of minus x is equal to minus of cos, that is substituting x is equal to minus x in the function f of x. So that means minus of cos x. Cos of minus theta is equal to cos theta. We know that because in the property of the trigonometric function, or also the property of the cos theta, we can say that is even function. So for that minus of cos of minus theta is equal to cos theta, and that is equal to minus of cos x, and the value which is equal to minus of psi x, that is phi of minus x is equal to minus psi of x. Therefore we can say that f of x is a odd function. As we come for the property of the definite integral, we know that my integral running from minus L to L f of x dx is equal to 0 if f of x is odd, and it is equal to 2 times of the integral 0 to L f of x dx if f of x is even. In the same manner, this is also we can define for the interval 0 to 2L. So that means when the function is odd, the function value is 0, and if it is even, then we can say that it is 2 times of the interval 0 to L f of x dx. And the product of two even function and the odd function, it will be even. We know that by the product of the normal, that is minus to minus and plus to plus, it is equal to plus. And if the sign of the two term is different, we can say that it is odd. If we come for the formula for the even function in the interval minus L to L for the coefficient of the Fourier series, we know that the Fourier series is f of x is equal to a naught divided by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity b n sin nx. Here the coefficient terms are a naught, a n and b n. According to the interval, how the coefficient terms changes in the odd and even function of the Fourier series. Let a naught is equal to minus 1 divided by L integral minus 1 to L f of x dx. Here f of x is even. Then we can say that it is 2 times of the 1 divided by L integral 0 to L f of x dx. So that means a naught is equal to 2 divided by L integral 0 to L f of x dx. As we come for the even function, the an value which contains both f of x as well as the cos are even. So that means the integral of term of the an, which is equal to 1 divided by L integral minus L to L f of x cos n pi x divided by L into dx, which is equal to 2 times of 1 divided by L integral 0 to L f of x cos n pi x divided by L into dx. As we come for the coefficient terms of the bn, the for bn which contains one is even and one is odd. As we know that the property of the product of one function is even and another function is odd, then the integral value which can directly we can say that it is equal to 0. Using the property of the odd and even function, the bn value is tends to 0. So for that, the Fourier series of the function f of x even, then we can write it as f of x is equal to a naught divided by 2 plus summation n is equal to 1 to infinity a n cos n pi x divided by L. In the second case, for the formula of an even function in the interval minus L to L, which is f of x is odd. If f of x is odd, then how the a naught value, bn value and an value changes? As we come for the function is odd, then a naught is equal to 1 divided by L integral minus L to L f of x dx is equal to 0. If the function is odd, directly we can say that a naught is equal to 0. As in the case of the coefficient term an, which contains the function f of x and the cos x, which is one is odd and another one is even. As knowing the property of the product of the even and odd function, the an is in the same manner. So that means we can write the integral of the odd and product of the odd and even function, it is equal to 0. As the coefficient of the Bn, which is contains both the function, that is f of x and sin x, are odd, then the integral, how it changes. See here, Pn is equal to 1 divided by L integral minus L to L f of x into sin n pi x divided by L into dx, and that is equal to 2 times of the integral 1 divided by L 0 to L f of x sin n pi x divided by L into dx. So that means Bn is equal to 2 divided by L integral 0 to L f of x sin n pi x divided by L into dx. As we know the coefficient terms of the Fourier series as a0 is equal to 0, an is equal to 0, and bn is equal to 2 times of 1 divided by L integral 0 to L f of x sin n pi x divided by L into dx. Substituting these values in the Fourier series, then the series it is f of x is equal to summation n is equal to 1 to infinity bn sin n pi x divided by L. And the table which shows the even and odd function for the interval minus L to L, in which condition the function of the Fourier series, what are the coefficient terms and how the series it is there. These are the some references that I used for making the video.